Okay, so we're going to now look at the higher paper from 2016, and we're looking at paper 2. So question 1, we have PQR is a triangle with vertices. P is 0, minus 4, Q is minus 6, 2, and R is 10, 6. For our first point for question A, part 1, we have to state the midpoint of QR. Okay, so midpoint is going to be equal to, so we're finding the average of these points. So Q, our x-coordinate is minus 6, and R, our x-coordinate is 10. And so because we're finding the average in those 2 points, we do that. And then our y-coordinates, so we've got 2 plus 6 divided by 2. So that's going to give us 4 divided by 2, which is 2, and 8 divided by 2, which is 4. So that's the midpoint of QR, M. So part 2 asks us to find the equation of PM, the median through P. So y minus b equals mx minus a for the equation of a straight line. We know the point M and we know the point P, so we can find our gradient. So M equals y2 minus y1 over x2 minus x1. And so we've got the point P, 0, minus 4, and we have the point 2, 4. So x2, y2, x1, y1. So we're going to have 4 take away minus 4 all over 2 take away 0, giving us 8 divided by 2, which is 4. So therefore, y take away 4 is equal to 4x take away 2. So I used our point M in that, and then so we need to multiply this out and see what we get. So we get 4x take away 8. So y equals 4x take away 4. Right, so part B is looking for the equation of the line L, which passes through M and is perpendicular to PR. Okay, so if they're perpendicular means that the gradients multiplied together give us minus 1. So if we look at that, we need to find the gradient of PR. So the gradient of P to R is equal to y2 minus y1 over x2 minus x1. And we've got the points P and R, which are 0, minus 4, and R, which is 10, 6. So x2, y2, x1, and y1. So we've got 6 take away minus 4 divided by 10 take away 0. So that's just 10 over 10, which is 1. So therefore, M perpendicular equals negative 1. So we're going to have y, and it's going through the point M, so y take away 4 is equal to negative 1 times x take away 2. So when we multiply that out, we get y take away 4 equals negative x plus 2. And after adding the 4 to both sides, we're going to get y equals negative x plus 6. Okay, so on to part C. Okay, so for part C, we have to show that the line L passes through the midpoint of PR. So the midpoint of PR is going to be, so P is 0, minus 4, and R is 10, 6. So we find the average of the x coordinates. and if we find the average of the y coordinates, so we've got minus 4 plus 6 divided by 2, and that should be divided by 2, not divided by 5. I'm skipping to the answer there. So 10 divided by 2 is 5, and then minus 4 add 6 is 2, so we get 5, 1. Okay, so to prove that that point goes through that line, if we have the equation of L, which is y equals negative x plus 6, so if we can substitute in one of our points, so x is 5, so therefore y equals negative 5 plus 6, which is 1, therefore it passes through the midpoint. Okay, great. Let's go on to question 2. Right, so question 2, we have to find the range of values for p such that x squared minus 2x plus 3 take away p has no real roots. Okay, so no real roots means b squared minus 4ac is less than 0. So for this equation we know that a is 1, b is minus 2, and c is equal to 3 take away p. Because it's everything that isn't a coefficient of the x or the x squared that is our c. So we're going to have minus 2 squared take away 4 times 1 times 3 take away p. It's got to be less than 0. So that gives us 4 take away, just sorting this out, 4 times 1, so 4 times 3 take away p is less than 0. So 4 take away 12 plus 4p is greater than 0. So that gives us 4 take away 12 is minus 8 plus 4p is less than 0. So therefore 4p is less than 8, not 0, 8. And p is less than 8 divided by 4, which is 2. Right, so for question 4, part A1, it asks us to show that x plus 1 is a factor of 2x cubed minus 9x squared plus 3x plus 14. Okay, so the easiest way to do this is to set up our synthetic division. So we're going to have 2 minus 9, 3 and 14. And if x plus 1 is a factor, then it's minus 1 that we're going to go through with. So we have 2, we times those two together, so we get 2 times minus 1, so minus 2, and then we add these, giving us minus 11. So we times the 1 and the minus 11, giving us 11. We add those two together, giving us 14. 14 times minus 1 is minus 14. So we've got 0, so therefore, as the remainder is 0, x plus 1 is a factor. Okay, right, so we can go into part 2, which says, hence solve the equation 2x cubed minus 9x squared plus 3x plus 14 equals 0. Okay, so we've been asked to solve the equation then. So we have 2x cubed minus 9x squared plus 3x plus 14 equals 0. So because we know that's a factor, we're going to have x plus 1, and then we're going to have 2x squared minus 11x plus 14 equals 0, and that comes from here, here. So our 2 becomes our 2x squared, our minus 11 becomes our minus 11x, and the 14 becomes plus 14. So now we have to factorize that second bracket. So 2x squared is going to have to be 2x and x, and so we're looking for the numbers for this. So we have 2x and we have x, And so we've got 14, so it's either going to be 14 and 1, 1 and 14, 7 and 2, or 2 and 7. So if we do this, we're both going to have to be, because we have a plus at the end here but a negative in the middle, that means they're both going to have to be negatives. So we're going to have a negative in here and a negative there. So when we're looking at this, we're going across the way because we multiply from the outsides and the insides. So we have 2 and 14 don't give us 11. We have 24 and we have 1 not giving us 11. We've got 4 and we've got 7, which does give us 11. So that's the one that we want. So we're going to have 2x take away 7 and x take away 2. Just to double check, when we multiply that out we get what we should. So we're going to have 2x squared minus 7x minus 4x plus 14. And the minus 7 take away another 4 is minus 11. So that's equal to 0. So therefore we have x equals minus 1. We've got x is equal to 7 over 2. And we have x is equal to 2. So those are our solutions to that equation. Right, so for part B, it's showing us a diagram below shows the graph with equation y equals 2x cubed minus 9x squared plus 3x plus 14. And we have the curve cuts the axis at A, B and C. So for part B1, we've been asked to write down the coordinates of A and B. So we found the coordinates of A, B and C in part 2 of part A. So it's x is minus 1, x equals 7 over 2 and x equals 3. So 7 over 2 is 3.5. So if we look at our graph, A has got to be our negative coordinate. So A is going to be, our x coordinate is minus 1 and our y coordinate is 0. And for B, B is the second coordinate along. So it's going to have the second, it's not going to be our 3.5, it's going to be our 2. So we have 2, 0. Okay, so for part 2 of part B, we've been asked to calculate the shaded area in the diagram. Okay, so when we're finding the shaded area, we're going to have to integrate, and we're going to be between minus 1 and 2, because that's what they've just asked us, of 2x cubed minus 9x squared plus 3x plus 14. Okay, so when we integrate that, we raise our power and then divide by our new one. So you get x to the 4, and then we're going to divide by the 4, so 2 divided by 4 is the same as a half. Okay, and then we're going to, for our next one, we're going to raise our power, so it goes from being a 2 to being a 3. We divide by the new powers, so minus 9 divided by 3 is minus 3. Next one, we raise the power, so it becomes x squared. We divide by the new power, so we get 3 over 2. And then our number just becomes 14x. So that's between minus 1 and 2. Right, so then we substitute in our values. So we're going to have a half of 2 squared minus 3 times 2 cubed plus 3 over 2 times 2 squared plus 14 times 2. Take away a half times minus 1 to the power of 4 minus 3 times minus 1 cubed plus 3 over 2 times minus 1 squared plus 14 times minus 1. So we just put that into a calculator, and once that's all been put into our calculator, we get the area is 27, so it is 27 square units. Of course, being careful to make sure that everything is put in brackets exactly how it's been written in, like how you've written out there. So like every bracket I have in my line before the 27 went into my calculator. Okay, so on to question 4. Right, okay, so we're doing question 4. So we've got circles 1 and circle 2 have equations x plus y squared plus y minus 6 squared equals 9, and x squared plus y squared minus 6x minus 16 equals 0 respectively. So write down the centres and the radii of circles 1 and 2. Okay, so circle 1, we can read it straight off from our equation. So our centre for circle 1 is going to be minus 5, 6, and the radius is going to be the square root of 9, which is 3. Okay, so circle 1 was easy. Circle 2 is a little bit harder, but not overly so. So from our equation, we're going to have that g is minus 6, f is 0, and c is minus 16. So it's 2g and 2f. So therefore, the centre is going to be 3, 0, and our radius is equal to the square root of g squared plus f squared minus c. So that means we're going to have the square root of minus 3 squared plus 0 squared minus 16, which gives us the square root of 9 plus 16, which is 5, because 9 plus 15 is 25, and when we square root that we get 5. So that is part A of that question done. So for part B, we've been asked to show that the circles do not intersect. So to find out whether or not these circles intersect, we need to look at the distance between the centres of the circle. So we're going to have minus 5, 6, and we've got 3, 0. Okay, so I find it easiest when I'm doing this to kind of draw it as a triangle, because to find the distance between them, we're going to have to use Pythagoras, or we can use the distance formula, but the distance formula is basically just Pythagoras anyway. So we've got 8 here. To go from minus 5 to 3 is plus 8, and to go from 6 to 0 is 6. Okay, so therefore distance is going to be equal to square root of 8 squared plus 6 squared, which is going to be the square root of 64 add 36. So the square root of 100, which is 10. Okay, so therefore, as R1 plus R2 is less than the distance between the two centres, they do not intersect. Okay, so if when we added the two radiuses together we got 10, then they would be just touching at one point. If we got something more than 10, they don't touch at all. Less than 10, then they do touch at 2 points, and then if it was 2, because of the difference between the radii, then they touch internally, and then if it's less than 2, then it would be, they wouldn't touch, but they'd be internal. Right, okay, so on to question 5. Okay, so we have a vectors question. We've got a picture shows a model of the water molecule. Relative to suitable coordinate axes, the oxygen atom is positioned at the point A252, and then we've got the two hydrogen atoms at B and C, and we've been asked to express A, B, and AC in component form. So AB is equal to B take away A. So to go from A to B, we do B take away A. So B is minus 10, 18, 7. And A is minus 2, 2, 5. So then we're going to have 10 take away minus 2, so that becomes 10 add 2, minus 10 add 2, so that's minus 8. I've got 18 take away 2, which is 16, and then I've got 7 take away 5, which is 2. Okay, so then AC is C take away A, which is minus 4 minus 6, 21, take away minus 2, 2 and 5. So I've got minus 4 add 2, which is minus 2. I've got minus 6 take away 2, which is minus 8. I've got 21 take away 5, which is 16. Okay, so for part B, we've been asked to hence or otherwise find the angle BAC. So when we're finding the angles with vectors, they've got to be going out, and that's A, B and C, so that's been really helpful. And so AB, the scalar product of AB and AC is going to be the magnitude of AB times the magnitude of AC times the cos of the angle in the middle. So we have to find our scalar product. So AB dot with magnitude of AB even, we'll do that first, is equal to the square root of minus 8 squared plus 16 squared plus 2 squared. Gives me the square root of 324, which is 18. Okay, so then we can find the magnitude of AC, which is the square root of minus 2 squared plus minus 8 squared plus 16 squared. So those numbers are the same. So we're going to get the square root of 324, which is 18. Okay, so the other thing we need to do is find our value of the dot product of AB and AC. So that is going to be minus 8 times minus 2, so we're timesing the x parts of our vectors, plus the second one, which is going to be 16 times minus 8, and then the last bit is plus 2 times 16. So that gives us 16, and then 16 times minus 8 is negative 128, and then we're going to be adding 32. When we do that, we get negative 80. Okay, so after rearranging, that means we're going to have cos theta equals magnitude AB, scalar product of AB AC, divided by the magnitude of AB times the magnitude of AC. So that gives us minus 80 over 18 squared, because it's 18 times 18. So therefore we're going to have cos to the minus 1 of minus 80 over 18 squared, and that is going to give us our theta, our angle. So our angle is in fact 104.3 degrees to 1 decimal place. Okay, so on to question 6. So question 6, first thing is we've been asked to state the number of bacteria present in the study. So we've got the scientists are studying the growth of a strain of bacteria. The number of bacteria present is given by the formula, where T represents the number of hours since the study began. So for part A, if it's at the beginning of the study, time is 0. So therefore, B of 0 is 200 e to the power of 0.107 times 0. So 200 e to the 0, and e to the 0 is 1, so it is just 200. So part B, the time taken for the number of bacteria to double. So when it's going to double, that means B of T is going to be 400. So we're going to have 400 equals 200 e to the 0.107 t. So we can then divide both sides by 200, giving us 2 equals e to the power of 0.107t. So now the base of our exponential can become the base of our logarithm, so we're going to get log to the base e of 2 equals 0.107t. So then we can divide by 1.07, so giving us t equals log to the base e of 2 divided by 0.107, which gives us that time is equal to 6.48 hours, and that's to 2 decimal places. Okay, so we have here a council, question 7. A council is setting aside an area of land to create 6 fence plots where local residents can grow their own food. Each plot will be a rectangle measuring x meters by y meters as shown in the diagram. Right, so part A is saying the area of land set aside is 108 meters, show that the total length of fencing L meters is given by what we have there. So, for part A. So first things first, so we know that the area is equal to 108 meters squared. The other thing we know about area is area, because it's a rectangle, is length times breadth. Right? So if we look at our length along the way, it's going to be 3x. So we have 3x, and we're going to times that by our height, which is 2y. Okay, so that would be 6xy. So we're going to have 108 equals 6xy, right? So, also what we're trying to find is we're trying to find the length in terms of x. So we don't want y in terms of our length, so we'll find y is equal to 108 divided by 6x. Right, so if we're thinking about the length of the fencing required, we can kind of think of it this way. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9x. Yeah? And when we're thinking about it in terms of our y, we're going to have 1, 2, 3, 4, 5, 6, 7, 8y. Right? So our expression we've been given has that 9x, so that's great. And then we've got plus 8, and we know that y is 108 divided by 6x. So we can sort that out, and this is in the calculator paper, so you can use a calculator to do that, to sort out your fraction. So you don't have to try and do this without. But we find that we get 144, and our x is still on the bottom, so we have proven that L of x is 9x plus 144 over x. Right, so for part B, we've been asked to find the value of x that minimizes the length of fencing required. So to minimize or maximize something, we need to find our stationary points. Okay, so at our stationary points, L dash of x is going to be equal to 0. Right, so we can start by getting this ready to differentiate. So we have 9x plus 144x to the minus 1. So we can differentiate this. So L dash of x is going to be equal to 9. And then we're going to times by our power, so we get minus, and then we're going to have 144x to the minus 2. Right, so when we do this, we are going to solve this for 0 equals 9 minus 144 over x squared. So we can solve this. So we're going to get 144 over x squared equals 9, which I'm going to move over here. So we're going to get, that gives us 9x squared equals 144. So that gives us x squared is equal to 16. So x equals plus or minus 4. Therefore, x must be equal to 4, as cannot be negative. Okay, so now that we have our value, we need to check using our nature table. So we have our value of x, and then we've got our value of L dash of x. So we've got 4, where we know we have 0 in there, so we know we have it being flat. So if we try 5, and we'll try 3. So if we put this into our L dash of x, so we're going to have 9 minus 144 over 9. So that is going to be 9 take away 16, so that's negative. So therefore we're going down. And if we look at it the other way, so we're going to have 9 take away 144 divided by 25. So 144 divided by 25 is just less than 6, so that's going to be positive. So we have a minimum value at x equals 4. So that is that question done. Okay, so question 8. We have expressed 5 cos x minus 2 sin x in the form k cos x plus a, where k is greater than 0 and a is between 0 and 2 pi. So we have a wave function question. So part A, we have 5 cos x minus 2 sin x, and we have to make it into the form k cos x plus a. So when we multiply this out, we would get k cos x cos a minus k sin x sin a. Okay, so that's just from your formula sheet. You don't need to remember those, right? So this weird looking 5 up here that I'm just fixing. Right, so if we look at our first bits, they've both got cos x, so they've got to be the same. So we have 5 cos x must be equal to k cos x cos a. So we can get rid of our cos x's, so we get k cos a equals 5. And from our other one, so we've got minus k sin x sin a is equal to minus 2 sin x. So we can both make them positive, and we can get rid of our signs. So we're going to get k sin a equals 2. Right, so you as well there, you need to explicitly state that k cos a is 5 and k sin a is 2. You can't just like show it in your working. You need to show it like you need to actually have it written specifically down as its own thing. Right, so from there we can then say that we know that k squared cos squared alpha, or a, plus k squared sine squared a is equal to 5 squared plus 2 squared. Okay, so we take out our k squared as a common factor, so we have sine squared a plus cos squared a equals 25 plus 4, so we get 29. Okay, we've just squared both sides and added them together, so it's kind of like simultaneous equations. Okay, so we're trying to find a way to get rid of it. So sine squared a plus cos squared a is 1, so we get k squared is equal to 29. So then we get k is equal to the square root of 29. Right, so we've got our k, so now we need to find our a value. So tan a is equal to k sine a over k cos a, because sine divided by cos is tan, so we have 2 over 5. Okay, so with our cast diagram, we know because sine and is positive, so it's those two, and cos is positive, so those two. So we're going to have it in our first quadrant. So we're going to get A equals the inverse tan of 2/5, and we're in radians for this one, so that gives us our A is equal to. So when we do the inverse tan of 2/5, we get 0.38050, and then it keeps going, because this is in radians, remember, not in degrees. So we get 0.38, which is to 2 decimal places. So therefore we can say from this that 5 cos x minus 2 sin x is equal to the square root of 29 cos of x plus 0.38. Right, so part B, we have the little bit that we've got from part A, so we got the 5 cos x minus 2 sin x equals root 29 cos x plus 0.38. So for part B we have a diagram shows a sketch of part of the graph of y equals 10 plus 5 cos x minus 2 sin x, and the line with the equation y equals 12. So we've got the line cuts the curve at points P and Q, so find the coordinates of P and Q. Right, so what we do is we're going to let y equal y. So we're going to have 10 plus 5 cos x minus 2 sin x is equal to 12. So we can then replace that 5 cos x minus 2 sin x with what we got in part A. So we have 10 plus the square root of 29 cos x plus 0.38 equals 12. So then we can take away 10 from both sides, giving us the square root of 29 cos of x plus 0.38 is equal to 2. So we then divide by the square root of 29, so we get cos x plus 0.38 is equal to 2 over square root of 29. So at this point, if we just do a cast diagram here, so we have cos and it's positive, so it's going to be our first and our last quadrants. So our relative acute angle, so our angle in our first quadrant is going to be cos to the minus 1 of 2 over 29, which is 1.19 to 2 decimal places. Okay, so that gives us then x plus 0.38 is going to be equal to 1.19, and is also going to be equal to 2 pi take away 1.19. So we have x plus 0.38 is equal to 1.19, and it's also equal to 5.09. So then x is equal to, so we're going to take 0.38 away from both of those. So we do 1.19 take away 0.38, which gives us 0.81. And we have 5.09 take away that 0.38, which gives us 4.71. Right, so we have question 9. So we've got f dash of x equals 2x plus 1 divided by the square root of x, and we also get told f of 9 equals 40, and we need to find f of x, right? So to find f of x, we need to integrate, because we've got the differentiated version, so we need to integrate to get it back to where we started. So before we can integrate, though, we have to get it into integrable form. So we have 2x over the square root of x plus 1 over the square root of x, because we can join our fractions together as long as they have the same denominator, we can split them apart as well. So x divided by the square root of x is going to be 2x to the half, because it's going to be index laws from National 5 are we take away our powers, so it's going to be 1 take away a half, so that is a half, and then this one is going to be x to the minus a half. Okay, so then we can say, well, f of x then is going to be the integral of 2x to the half plus x to the minus a half with respect to x. So when we integrate, we raise our power, so a half will become 3 over 2, and then we divide by our new power. So dividing 2 by 3 over 2 is the same as multiplying by 2/3, so we're going to get 4 over 3 because it's 2 times 2/3, which is 4 over 3, and then plus this one again, x, our power goes up to a half, and then we divide by a half, which is the same as timesing by 2, and then we have plus c. So then we know that f of 9 is 40, so we know that 40 is going to be equal to 4/3 of 9 to the power of 3 over 2 plus 2 times 9 to the power of a half plus c. So we get 40 is equal to, that is the square root and then cubed, so we have 4/3 of 327 plus 2 times 3 plus c. Right, so when we sort that out, we get 40 is equal to 42 plus c, so therefore c must be equal to minus 2. So therefore f of x is equal to 4/3 x to the power of 3 over 2 plus 2x to the half minus 2. Okay, so that's question 9. Right, so question 10, this is quite a nice one actually towards the end. So we have, given that y is equal to x squared plus 7 to the power of a half, we need to find dy by dx. So dy by dx, so when we're multiplying like this, what we do is we bring down our power. We also multiply by whatever we get when we differentiate that bracket. So x squared plus 7 differentiates to give us 2x. And then we're going to have x squared plus 7, and then we reduce the power by 1, so we get negative a half. So a half and 2 cancel each other out, so we get x squared plus 7 to the minus a half, or we can kind of rearrange that, kind of slightly looking ahead to part 2, to x squared plus 7, so x over the square root of x squared plus 7. Right, so for part B, we've been asked to find the integral of 4x over the square root of x squared plus 7. So all we've got there is we've got 4x over square root of x squared plus 7 dx. If we think about that, it's just like 4 lots of the integral of x over the square root of x squared plus 7, because when we integrate we can take out a constant. So it's going to just be 4x squared plus 7 to the half plus c. So that's it for question 10. So last question now, question 11. Right, so for question 11 part A, we need to show that sine 2x tan x equals 1 minus cos 2x. Right, so starting with our left-hand side. So we're starting with the left-hand side of the equation. We're trying to get to 1 minus cos 2x, right? So, so we have sine 2x tan x. Right, so sine 2x we know is 2 sine x cos x. that's on our equation sheet. Right, so we have 2 times sine x times cos x times tan x. Right, so we're kind of getting a little, maybe even slightly a little bit closer, we think, maybe. Right, so then tan x is sine x over cos x, so we're going to have 2 sine x times cos x times sine x over cos x. Okay, so we can cancel these out, so we get 2 sine squared x. Right, so we're kind of there, we've not quite got to what we want. So if we think about it, sine squared x plus cos squared x is equal to 1, so we can rearrange, because we're looking for cos, we don't want sine, right? So we can say that cos squared x 1 minus cos squared x is equal to sine squared x. Right, so we're going to get 2 times 1 minus cos squared x. So we have 2 minus 2 cos squared x. Okay, so from there we can, so we need to have cos 2x in this. So we know that cos 2x is equal to 2 cos squared x minus 1. Okay, so we can kind of rearrange that. So we can say 2 cos squared x is equal to cos 2x minus 1 plus 1. Yeah? So if we substitute that in, we get 2 minus cos 2x plus 1. And then if we kind of multiply our brackets, so we're going to get 2 minus cos squared cos 2x minus 1. So we get 1 minus cos 2x, which is equal to our right hand side. So that is us proven that part there. Okay, so for part B, we've been asked, given that f of x is equal to sine 2x tan x, we need to find f dash of x. So we can say that is equal to 1 minus cos 2x. So when we differentiate, what happens is if we look at our kind of thing, sine goes to cos goes to minus sine, and minus sine goes to minus cos. And then it goes back to the start of our loop. So what happens is we can then say, so 1 when we differentiate goes to nothing, minus cos goes to sine, our 2x stays at 2x, and we have to multiply it by 2. So our final answer for f dash of x is 2 sine x 2x. And that is us for paper 2. So I hope that's been really helpful. If it has, please let me know, please subscribe, leave any comments if you've got any other questions, and watch some of my other videos about parts of the higher course. And obviously I've got videos for the other past papers that are there as well. So thank you for watching, and that's me.